Hi, I'm Mr. Raza and I'm going to be teaching you some maths. Today we'll be looking at recurring decimals and fractions. As a quick warm-up, we want you to just quickly use a calculator for the more complex fractions, convert these fractions into decimals. I'll just give you a few more seconds to tackle that and then we'll go through them together. So 1/4 we should know already as 0.25. 2/5 we should know as 0.4. 1/3, how many decimal places shall we write this to? We know that it's 0.333, as many threes as you can fit on your screen or paper, which of course can be expressed as 0.3 recurring. There should be a little dot above the 3 to indicate that the 3 is recurring. 3/10 is the equivalent of 0.3 without the recurring. 18/99. This is where we need our calculators. Our calculator display should be shown as 0.181818 recurring. Of course, it's the 1 and the 8 that's recurring, so we need a dot over both. Notice on the PowerPoint display that the dot is next to the 1 and the 8, but it should be high, and when you're handwriting, please put the dot above the 1 and the 8. 1/6, from memory or from the calculator, is 0.1 with as many 6s as you care to write, which of course indicates that the 6 is recurring, so we do not need the dot over the 1, whereas 0.16 recurring is the correct presentation. The objective of today's lesson is to go the other way round. We have recurring decimals and we need to express them as fractions. Once you get used to the procedure of recurring decimals being converted to fractions, you will be able to follow and understand the recurring decimal proof. All recurring decimals can be converted into fractions. To convert a recurring decimal to a fraction, introduce a variable, usually x. Form an equation by putting x equal to the recurring decimal. Multiply both sides of the equation by 10 if 1 digit recurs, by 100 if 2 digits recur, for example the 0.18 recurring, and by 1000 if 3 digits recur, and so on. With the 0.16 recurring, be careful, because although it's written to 2 decimal places, it's only the 1 digit that's of 6 that recurs. Then we're going to subtract the original equation from the new equation. So let's put this into practice. Of course, we'll rearrange to find x as a fraction. The example we're going to use is 0.29 recurring. We want to convert that into a fraction. We will label that decimal as x. Now, do we agree that